Today we are going to discuss about the topic oscillatory system. So in this lecture, I am to discuss about what is oscillatory system, what is oscillatory motions, and the different types of oscillatory motions, what is the characteristic of oscillatory motions, and discuss one example in what is going on in day-to-day life. Let's first discuss about what is oscillatory system. As the word, it's the oscillatory. Oscillatory system means the system which performs the oscillations. Then question arises, what is oscillations? Oscillation is a type of oscillatory motion is a type of periodic motion. Periodic motion means the body retraces its position at constant interval of time, then it is called the periodic motion. But still there is a difference between the periodic motion and the oscillatory motions. So let me differentiate these two. Suppose for example, if you take if the earth moving around the sun, and with the position of the sun and earth is revolving around it at any instant time, suppose this position, here you find that at t is the position of the earth. If you see if you after 1 year you find the same position of the earth. So this is the periodic motion. Okay, but in the oscillatory motion, it is mostly to and fro motion. To and fro motion. To and fro motion about the mean position. Suppose this is the body. This is the body. This is the mean position. That means we start from here and again moves to this side, again moves to this side, and this is the main position. So this is called the to and fro motions. So difference is that every oscillatory motion is periodic, but every periodic motion is not oscillatory. That's the main difference. So now the question is, what causes the body to oscillate? So that is two factors or two physical parameters. One is the elasticity, another is the inertia. Because of suppose this body from here, okay, suppose I apply some force, the body goes to this direction, and suppose at this position. At this position, when it is here the potential energy is maximum, then I am kinetic energy 0, then he tries to bring back to this from the rest position. Why? Because the elasticity that exists inside the body that is responsible to bring back to this position, that is called the restoring force. Because the restoring force this back to this position, but at that time the potential energy decreases, kinetic energy is the body attends the motion, and due to the motion and due to the inertia the body moves to this direction. And again at the extreme end, again the restoring force acts on the body, again it moves to this direction. That way it is execute the oscillatory motions. In the day-to-day life, you see examples, all of you have to experience. One good example I can give, the vibration of the string, the vibration, atomic vibration in the solid, the vibration of electric and magnetic field, because of which the electromagnetic wave propagating. These are the few examples of oscillatory system. So based upon the force acting on the system, force acting on the oscillatory system, there are basically three types of oscillatory motion. One is the simple harmonic motion, one is the damped harmonic motion, or damped oscillation, and the forced oscillations. So let me first explain what is the simple harmonic oscillation. So simple harmonic oscillation is the oscillation where force is directly proportional to the displacement. So if I take the but here, the what kind of force is the force only for the restoring force acting on the body. So restoring force is proportional, but in damped and forced harmonic oscillation, there is apart from restoring force, there are other forces, external forces, there are periodic force, other forces. No need to, now timing we will discuss only the simple harmonic oscillations. So in simple, as I said, simple harmonics of force, that the restoring force is proportional to displacement, and this negative sign shows the force is in just opposite direction. The force is opposite to the displacement. So this is the equation. If you know the Newton's laws of second law of motion, force is directly proportional to the acceleration. That means force equal to, mathematically I can say force equal to mass into acceleration, and this is proportionally constant. I can write that constant is my k. K is the proportionally constant, that is the force constant called. So that means here I can say I can write d square x by dt square. This is the acceleration. Okay, that is equal to kx. So if you simplify this, simply we get d square x by dt square plus k by m x equal to 0, or I can simplify this, d square x by dt square plus omega square x equal to 0. So this is a second order linear differential equation. So if you solve this equation, then final equation will get x is equal to a cos omega t plus theta. This equation actually tells the characteristics of all the characteristics of simple harmonic oscillation. So what is the characteristic? Here A is the amplitude, which is nothing but the maximum displacement. Omega is the angular frequency, and theta is the initial phase, and omega t plus theta is the total phase. And other parameters also you calculate. If you take dx by dt, then you can calculate the velocity. From velocity you can calculate acceleration, and if you know the velocity you can calculate kinetic energy. And if you take the integration potential energy kx 0 to x equal to this one, you dx, you calculate the potential energy. If you know kinetic energy potential, then you calculate total energy. Then that's why from this equation all the characteristic property of the simple harmonic motion you can calculate. Let's take an example what is going on in day-to-day life on the simple pendulum. The simple pendulum. Actually, the simple pendulum consists of a massless inextricable string, and one of the end is attached to the rigid support, and other end carrying a point mass. This is our support, and the point now is moving freely. Suppose and when you apply the force, or when you draw it and release it, you should execute the oscillation. And let's consider a oscillating simple pendulum at any instant time, suppose t, and this time this is the theta is the angular displacement. And this is due to the weight. Suppose this the mass is m, due to the weight is mg, and we resolve this component weight into two components, mg cos theta, which is balanced by the tension of the string, and this is the tangential force, that is mg sin theta, which is nothing but provide the restoring force. Now, if you apply according to the force is proportional to the displacement, that means here the force is restoring force. So mg sin theta is equal to at this point, what is the displacement? Displacement is L into theta. So if you apply the Newton's second law, this becomes n d square L theta into dt square. So if the oscillation, this displacement is very small, then sin theta becomes theta. Sin mm cancels, so minus g theta, this becomes d square L theta. L is constant over here, I can write L d square theta by dt square. And if you simplify further, d square theta by dt square plus g by L theta equal to 0, and you further simplify, this becomes d square theta by dt square plus omega square theta equal to 0, and omega is nothing but g by L. G is the acceleration due to gravity, L is the length of the string, and from this we can calculate time period T is equal to 2 by L by g. And if you solve this equation, you can also find out all the properties of the simple pendulum. So with this we conclude. So in this lecture what we discuss what is the oscillatory system, what is the oscillatory motions, types of oscillatory motions, and what causes the oscillations, and we discuss, we derive the equation of the simple harmonic oscillations, and we discuss about one of the example, that is the simple pendulum. So with this we conclude this lecture. Thank you.